we are going to solve the Leetcode biweekly contest 82nd problem. Successful pairs of the spells and the question. So uh, I think if you have read the question, first read the question, try it out, then check the solution video. So let me tell you, this is the array 1 and this is the array 2. Like if we are going to this array, like if we take this element and multiply with all this element, we need to tell like how many elements in this portion from the multiplication. Like if we take the 5 and this all the element, how many elements are like greater than equal to success, like it is 7. So it is like the uh, basic question, like easy to understand the question. So if you check it, this is if we going to check the brute force approach, then it is the n square, like n into m. So but it will not giving me permission, like the constraints are like only allows like uh, o of n or o of log n log n. It only allows this sorry, it only allows the n or n log n constraints. So let's check like how we are going to solve it. So like the first idea is came into mind, like the binary search. Like the order does not matter over here. So if we can sort it, if we are going to sort it like and find it at the minimum index, like uh, whatever the element is going to this. So let me tell you with the example with 513. uh, what is it? 513, this is the array 1 and 1 2 3 4 5. 1 2 3 4 and 5. If we check like 5 cross 1 and the success is like 7. If we check like it is not matching the like condition, so we are not going to take it. If we match like 5 cross 2, it is 10 and it is matching the condition. All the other elements which is greater than equal to this element, if first we need to sort it, also satisfies the above condition, like 5 cross 3 15, which is greater than 7. 5 cross 4 like 20, which is greater than 5 cross 25, which is greater than 7. Let's check for the 1 cross 1, no. 1 cross 2, 1 cross 2 2, which is not. 1 cross 3, no. 1 cross 4, no. 1 cross 5, so this element gives me answer the 0. This element is giving me the answer for this. Like if we find out, it is like forming the monotonic function. For the 0th index it is giving me false, for the 1 index true, for second index is true, for the third index is true, for fourth index is true. I just need to find out the this changing part. If I find out this changing part, I can easily find n minus 1. Suppose this is idx. Suppose this is idx, index minus index. This is giving me the correct output, like 5 minus 1 4, 4 minus 1 is 3 plus 1. We are forming the 0 bits index. So this is giving me the how many in uh, how many elements are satisfy this condition. We just need to iterate over this loop, like for spells loop, and we are going to binary search on this loop. So if we can do this, if you get this idea, so let's take an example for this 3. If we multiply 3 into 1, that is not giving me the answer. 3 to the 6, which is not giving me the answer. It should be greater than equal to 7 actually. Success, whatever the success is this. So let's check with the 3 3s are 9. Yeah, it is giving me the answer. 4 3s are 12. It is definitely giving me the output. 5 3s are 15. It is definitely giving me the output. I just want to check like how many elements satisfy this condition for the particular I. So if satisfy this condition, if we find out like for this the monotonic function will going to return this thing. If we find that this first true value, so we are enough, like we are going, like if the length we know that is n minus 1 minus idx, that is the idx is the first true which are getting, plus 1, because we are forming the zero based indexing. So let's see the code for this. You can definitely dry run for this also. So first we are taking and check for the uh, data type which is giving this, because success is going to 10 to the power 10, which is exceeding the integer limit. So first we need to sort the portion. This is the spells array and this is the portion vector. So we first need to sort the portion in the increasing order actually. Then we are going to take the answer. And for every, like for what we are going to output is the, like the answer for each, like for the 5 how many elements are satisfy this condition, that is the 4. For 1 it is 0. For 3 it is only the 3, that is 3, 4 and 5 which satisfy the condition, like how many elements. So for we need to get like answer of n elements, and we are going to return that answer after calculating for each I. Then we are iterating over each I in the spells. The current element is this, the current element is s of I. So first we need to like forming the index actually. This let me it is not the count actually, it is idx and index. Then we are going to binary search on the p, like the portion. For this we need the success in the current element for the multiplication, right? We are going to point out low is equals to 0 and high is equals to n minus 1. Like in for the binary search we are going to like uh, let me tell, sorry, uh, let me, so suppose this is your portion array. This is pointing at the low and this is pointing at the high. This is the indices, and if we calculate the mid, then I have to check, okay, whether it is giving me the true or the false for this, true or false. If it n minus 1 for the high, and this remember this is the portion array, portions. So answer is equals to high, that is like you can take the minus 1 as well, depending upon you, but you don't have to take like the positive. Either you have to take any of the like minus 1 minus 2 from the left side, from like it I always start with a 0 1 0 1 2 3, or you have to take like n comma n plus 1 or any value that does not come. So for like we need to binary search on this. Low is less than equals to high, like low and high should like maintain the position. It does not exceed, like low does not come over the high or a high does not come here apart from the low. We are calculating the mid, and we are calculating the temporary value, that is the p of mid. P of mid is like the portion of mid, whatever the value is this, into uh, the the spell of I, s of I, whatever the element is, like the p of, suppose it is j, suppose it is mid actually, mid, p of mid into s of I. We are calculating if we got the true over here, like it is giving me the true actually, then I know like my answer is going to lie from this to this. Okay, we need to find the first true. It is going to take like it, possibly it is the answer. So I am going to answer is equals to mid, store this index, and high is equals to mid minus 1. So my search space reduced to low. Low remains the low remains this and my high is pointing over here. Now my mid is like here, and if it is giving me the false, then my low is equals to mid plus 1. For this you need to know the concept of binary search on answer. Let me write it. This is very important concept on binary search. Binary search on answer. If you go to the Unacademy, there you will find Unacademy portal. You will find 2 3 videos which is the good for the this concept. If my answer is equals to n, like it is not giving me, like there is nothing element, no element that satisfy this condition. So like for the this element it is going to taking me 0, like there is no element. So my answer is equals to -1. I'm going to return -1, but you have to check like for how many elements. If the index is equal to -1 or anything you defined it, then my answer of I is equals to 0. Okay, answer for this particular element for the one, answer for the 1 is equals to 0, or else it is anything like my there are the index from 0 to n minus 1, anything. Then my answer is like how many elements, m, number of the elements in the p as you have defined. M is used to p dot size minus 1 minus index plus 1. Plus 1 is because we are forming like a zero based indexing, following the zero based indexing. So we are going to the return the vector. If you going to check, like it is passing all the output, 403 if I'm going to submit it, um, pending, it is running, accept it. So hope you like it. If you don't understand anything, then please let me know in the comment section. Thank you. I'm going to put all the codes in the comments, like in the description. Thank you.